In this section, I'm solving quadratic equations by factoring. Okay, let's consider. I want to find x that makes this a true statement. And here's how we do that. First thing that I do is I bring that 18 over to the left-hand side of the equation and get the equation into what's called standard form. The standard form means we have it of the form ax squared plus bx plus c equaling 0. Okay? Now I take a look at this trinomial. Now remember, if I have x squared, 3x, and 18, that's called a quadratic trinomial. And since we have introduced this equals 0 piece of it over here, that's where the equation comes in. We're trying to find x's that make this a true statement. In order to solve this, here's what we do. I'm going to factor this side of the equation. And that turns out to be x minus 6 times x plus 3. And that's all equals 0. Now what we do with this now is that we realize that if we have two things that are multiplied together to get 0, we're going to use a thing called the zero factor theorem. And that tells us that got two things multiplied together to get 0, one of them or both of them have to be equal to 0. So we take the x minus 6 and say, well, what makes that equal to 0? Or we take the x plus 3 and say, what makes that equal to 0? And solve each one of those individually. This one, of course, x equals 6, and this one, x equals negative 3. So we say the solutions are 6 and negative 3. So to solve the quadratic equation, and what we did is we put it in the standard form, factor it, apply the zero factor theorem to find our results. Okay, let me clear the board and we'll do another more complex example. Okay, here's the example. 2x cubed minus 18x equals 0. Now, this isn't exactly in standard form, but it is equal to 0. Anything we can do with that? Let's jump to that factoring, that left-hand side. Remember, the first rule of factoring a polynomial is to see if there's anything in common that you can factor out first. And sure enough, this does. In fact, the greatest common factor of these two terms turns out to be 2x. When we factor out the 2x, we're left with x squared minus 9. That whole thing equals 0. Now we're in the position where we can recognize this x squared minus 9 as the difference of two perfect squares. So we can factor that some more. And that's going to be equal to x minus 3 times x plus 3, all equaling 0. Okay, so make sure that when you have an equation that you want to solve by factoring, you want to factor it completely before you go any farther. All right, at this point, we can use the zero factor theorem to say that we've got three things multiplied together to get 0. That means any one of the three could be equal to 0. So let's test them out. 2x equals 0, x minus 3 equaling 0, or x plus 3 equaling 0. Well, let's see, 2x equals 0 only when x equals 0, so that's one of them. Add 3 to both sides here, we get x equals 3 as another solution. And then x equals negative 3. So we get three different solutions for this. We get 0, we get 3, and we get negative 3 for our solutions. So we've solved this equation, and it turns out the quadratic factoring helped us here. We solved the quadratic equation by factoring, factored it into three factors that multiply together to 0. That means we applied the zero factor theorem, took each one of those factors, and figured out what would make that 0. And we ended up with three answers in this particular example.